Okay, so if you missed a lesson from 1-2, we're going to fill in the blanks in our notes and just talk about what we have here. Kinematics is the unit that we're really into. We're going to talk about for the next little while. And kinematics is all about studying motion and not worrying about where the motion is coming from, why it's moving. It's just how are things moving and how are they related. When we talk about position, we're always talking about the location where something is relative to a coordinate system. So we're going to have our own spot that we say this is 0, 0. We'll label that in our pictures or in our problems, and then from there, any position that coordinate system is going to be a reference frame. And the most common one we use is the XY axis system. Just really easy to draw and easy to work with. Yeah, we live in a three-dimensional world, and sometimes we'll get into that, but generally we're going to do two-dimensional motion to make it simple. When we talk about displacement, it's not just how far something's traveled. It's actually directional as well. So you see that we have the change in x is equal to the final position minus the initial position. That's what our xf minus x naught represents. It is a vector, which means it has direction and magnitude. The path that it takes does not matter. We only care about its final position compared to its initial position. And so in the picture here where we talk about the displacement of the graph, you can see that it went from -5 units out to +7 units. Even though it turned and made a loop-de-loop along the way, the reality is it moved a total of 12 units from its initial position to its final position. When we measure distance, however, it's the length of the path traveled. This is a scalar where direction does not matter and we only have magnitude. So a lot of times we're going to see that our distance is much more than our displacement. If you think about going around a track, if you run one lap on the track, your displacement is 0, but your distance covered is 400 meters. So this is an example. If you drive 20 kilometers east, we'll call that positive, and you turn around and drive 15 kilometers west, we call that negative. The displacement, you really will have only moved 5 kilometers. However, you traveled a distance of 35 kilometers. There's a time and a place for each of those measurements to matter to us. And that's all you really need for your displacement and the basic understanding of vectors. We'll see you in class.